We're going to continue on with section 5.2 and doing integrals involving logs. So number 7 in the notes. So number 7 says the integral, and I don't like t, so I'm going to change it to x, of x plus 1 over x dx. All right, on this one, we can't do it the way we have been doing it with choosing the denominator to be x. You never want to choose u to be just be x. So here's the thing. You have to come up with other ways to do it then. For this one, if your denominator is a monomial, try breaking it up to multiple fractions. So x over x plus 1 over x dx. So if your denominator is a monomial, just take each piece in the numerator and put it over it. Well, then that simplifies to the integral of 1 plus 1 over x dx. We can do that fairly quickly. It's not a problem. So the integral of 1 is x. The integral of 1 over x dx is the natural log of the absolute value of x plus c. And we're done. That's it. So sometimes breaking them up into smaller fractions is nicer. All right, number 9. The integral of x squared plus x plus 1 over x squared plus 1 dx. All right, this one also does not work into what we did before. So when you choose u to be the denominator, typically that will work if the degree of the top is 1 less than the degree of the bottom. If you notice, we did not have that in the top case. Up here, my degrees were the same, x to the first over x to the first. Also here, I have x squared over x squared. There are different ways to do this, but I want to show you a way that will always work that you're not going to like. We can simplify this using long division and do the top, our numerator, x squared plus x plus 1 divided by x squared plus 1. So if you remember your polynomial long division from Algebra 2, x squared goes in x squared once. 1 times x squared is x squared. 1 times 1 is 1. Once we draw that, you want to draw your line, change all your signs. Your first term should always cancel out. Well, here, your x and your 1 and your 1, positive 1 minus 1 will also cancel out. So once I do this, I'm going to be left with just x. That is my remainder. So we always put our remainder over our divisor, what we are dividing by. So I can rewrite this as the integral of 1 plus x over x squared plus 1 dx. So now I have, excuse me, 2 terms now that I can do. The integral of just 1, I can do that. That's not a problem. This is now in the form we like what we were doing in the last video, where the denominator has a degree 1 higher than the numerator, or the numerator is degree 1 less than the denominator. So I'm going to break this up, and I'm going to do the integral of 1 dx plus the integral of x over x squared plus 1 dx. All right, so now that I have that, it's not horrible. The integral of 1 dx is just x. Plus, in order to do this, the second integral now, I need to use u substitution. So u is going to be my denominator, which is x squared plus 1. So du dx is 2x. So du is 2x dx. So I get the integral with u in the denominator. Remember, I want it to match up. What do I have left? What I have left in my integration is x dx. It doesn't match up exactly. I need to make that work. So I'm going to divide by 2. 1/2 du is x dx. So now it does match up exactly. So I can go ahead and plug that in. So I'm going to get rid of my x dx up here and replace it with 1/2 du, what it actually equals. There's nothing left in the numerator, so I leave that as a 1. So my x just comes on down, plus 1/2. The integral of 1 over u du is the natural log of the absolute value of u plus c. All right, so now I can clean it up. X plus the natural log of, remember 1/2 becomes the exponent. 1/2 as an exponent means square root. The absolute value of u, as we can see right up here, is x squared plus 1 plus c. So this is the answer we are looking for. All right, let's do another one. Number 12 in the notes, which says the integral of x times x plus 2 over x cubed plus 3x squared plus 4 dx. All right, so the first thing I want to say is, can I do this by my nice method of picking the denominator to be u? Well, is my degree on the top 1 less? It is, but I would rewrite it, distribute that x. When you distribute the x, you get x squared plus 2x all over x cubed plus 3x squared plus 4 dx. So now you can see the degree on the top is 2. That's 1 less than the degree on the bottom, which is 3. So that my u substitution will most likely work. So u is going to be my denominator, x cubed plus 3x squared plus 4. The derivative of that, du dx, is 3x squared plus 6x. So du is 3x squared plus 6x, that whole thing, times dx. So go back to our integral now. I get the integral. The denominator is u. Again, remember, I want everything that's left to match up over here. It doesn't, but I can make it match fairly quickly. Pull a 3 out. Du is 3 times x squared plus 2x dx. Then I can go ahead and divide each side by 3. So 1/3 du is x squared plus 2x dx. So now that that does match with what I have left circled in the red, I can get rid of the x squared plus 2x dx and replace it with 1/3 du. 1/3 out front, du out back. There's nothing left in the numerator, so put a 1 there. So now I can integrate it. I get 1/3 the natural log of the absolute value of u plus c. So remember, u is the denominator, that old denominator, x cubed plus 3x squared plus 4. So I'm going to get the natural log of the cube root, because it's 1/3 out front, means it's going to be 1/3 as an exponent, which means the cube root, of the absolute value of u. So as I just showed you, u is x cubed plus 3x squared plus 4. The absolute value of that, plus c. And that's what we're looking at. All right, I will do one more video. I think I can get it in here. Let's do some trig. So if you look at the notes that were posted, now we can do the integrals of the 6 basic trig functions. Other than sine and cosine of an angle, the rest of them involve logs. So let's go ahead and see how to do this. So number 14. The integral of the cosine of x over 2 sine x plus 3 dx. All right, well, what we were saying before is we want the top to be a degree less than the bottom because we want it to be the derivative. If it involves trig, you still want the same general thing. Does the top, the numerator, involve the derivative of the denominator? Yes. So our typical u substitution will work. So if we choose u to be 2 sine x plus 3, the derivative of that, leave the 2. The derivative of sine x is cosine x. The derivative of 3 goes away. So I get du equals 2 cosine x dx. So I get my integral. The denominator is u. What I have left is cosine x dx. I want that to match up over here. I just have to get rid of that 2. So I'm going to do 1/2 du equals cosine x dx. So now I can get rid of the cosine x dx and put in 1/2 du. Nothing in the numerator, so we put a 1 there. So now we can go ahead and integrate it. So I get 1/2 the natural log of the absolute value of u plus c, which gives me the natural log of the square root, because it's 1/2, of the absolute value of u. Well, u is 2 sine x plus 3. All of that plus c. So that's what I'm looking for. I will do one more video for this section with doing a few more trig problems.